Hello, everyone. When we think of gold mining, our minds immediately picture workers covered in mud and soot, digging hundreds of meters underground in dark, perilous mine shafts in South Africa, Australia, or the deep jungles of the Amazon. But today, I want to invite you to look at a completely different type of mining, a concept that is exploding in the 21st century, urban mining. There's an astonishing truth that very few people pay attention to. The gold content hidden within electronic waste is 10 to 50 times higher than that of natural gold or buried deep in the earth. To extract just 1 single gram of gold from natural mines, people have to dig up, transport, and process more than a ton of raw or using massive machinery. Meanwhile, an amount of old phone circuit boards weighing about 41 kilograms, equivalent to a few hundred to 1,000 old smartphones, is all it takes to gather that exact same amount of gold. Every year, our world discards more than 50 million tons of electronic waste, or e-waste, ranging from computers, televisions, and refrigerators to the smart devices we replace annually. Most of this waste from developed nations like the United States, European countries, or Japan is not recycled domestically. The reason is that labor costs, they're simply too high, and environmental protection standards are extremely strict. Instead, it is packed into massive shipping containers, labeled as secondhand goods, and exported to developing countries. In Pakistan, major cities like Karachi or Lahore have transformed into global, giant electronic waste dumps. Here, slums like Lyari or the desolate outskirts of Karachi have seen the rise of unique, artisanal recycling workshops. Thousands of families, including men, women, and even children, rely on operating on these old tech devices for their survival. This is by no means a high-tech industry with automated machinery or modern robotics. It is a primitive, manual livelihood, brutal, unforgiving, and riddled with deadly hazards. Right now, we will dive deep into each step of this fascinating yet dark gold extraction process in Pakistan. The first stage of this journey is called sorting and mechanical dismantling. The artisanal industrial process in Pakistan begins entirely with manual labor. After arriving at the port of Karachi, the e-waste is piled into mountains at open-air workshops. Poor laborers, without any protective gear other than their bare hands, use hammers, pliers, and screwdrivers to smash the plastic casings and metal frames of the devices. They quickly sort the waste into distinct piles. Plastic is sold to low-end plastic recycling shops, while iron, copper, and aluminum are gathered to be sold to metallurgical foundries. However, the most valuable part, often referred to as the heart of the junk pile, is the green or blueprinted circuit boards, also known as motherboards. On these boards, the contact pins, SIM card slots, RAM slots, CPU socket pins, and tiny circuit tracks are where the highest concentrations of gold, silver, and palladium are hidden. Gold must be plated onto these specific locations to ensure perfect electrical conductivity and to prevent the components from oxidizing over time. After sorting, workers use pliers to clip away plastic parts or metal sections that do not contain gold, minimizing the bulk to prepare for the next step. To detach small components from the large circuit boards, workers in Pakistan do not have sonic separators or temperature-controlled ovens like those in Western countries. Instead, they use an incredibly crude but effective method, desoldering using industrial gas stoves or direct blowtorches. They place the circuit boards over an open, blazing gas stove or torch the backside of the board directly. When the temperature reaches about 200 to 250 degrees Celsius, the tin solder holding the chips and pins begins to melt. At that exact moment, the worker simply slams the board hard against the ground or uses tweezers to quickly pry them off. Hundreds of microprocessors, capacitors, and gold-plated pins shower down onto the floor. This is precisely where the dark side of this industry reveals itself. When the plastic boards and solder are heated directly at high temperatures, they release a thick, jet black, foul-smelling smoke. This smoke is filled with toxic chemicals like dioxins and furans, lethal substances capable of devastating the respiratory system and causing cancer in humans. Yet in these artisanal workshops across Pakistan, there are virtually no smoke filtration systems or chimneys. Laborers, including the young children helping out, inhale this toxic plume directly day after day without any specialized masks or respirators. Once a large quantity of small, gold-plated components has been gathered, the process moves into the second stage, using chemicals to strip away the base metals. The goal of this phase is not to dissolve the gold immediately, but to strip away the less valuable metals like copper, iron, and nickel that heavily encase the gold layer. This is known as acid leaching. In Pakistan, people build small concrete basins outdoors or simply use large plastic barrels. The gold-plated components are poured into these containers, and then workers pour industrial-grade nitric acid directly inside. The moment the acid makes contact with the metal, a violent chemical reaction erupts. The nitric acid aggressively attacks the base metals like copper, iron, and nickel. They are corroded and completely dissolved into the liquid, turning the solution in the basin a dense green or deep blue color. This reaction generates an immense amount of heat, causing the solution to boil violently and releasing massive volumes of nitrogen dioxide gas, which appears as a thick, reddish-brown plume. This is an extremely toxic gas with a suffocating, pungent odor and highly corrosive properties. When inhaled, it reacts with the moisture in human lungs to form nitric acid right inside the body, causing immediate bronchial burns, respiratory distress, and potentially death with prolonged exposure. In the e-waste markets of Karachi, these ominous reddish-brown clouds frequently billow into the sky, merging into the air without any form of control or treatment. Because gold is a noble metal, it is entirely unaffected by nitric acid. Therefore, as the underlying copper and nickel layers are eaten away by the acid, the paper-thin gold plating on the outside naturally flakes off. After a few hours, when the reaction stops and the basin cools down, the workers drain the solution. Unfortunately, this green liquid, loaded with toxic copper salts and residual acid, is usually poured directly into public canals or drainage ditches, seeping straight into the community's groundwater. The remaining residue at the bottom of the basin is washed multiple times with water by the workers. At this point, they harvest tiny, glittering gold flakes, though they are still mixed with a bit of undissolved plastic debris and fiberglass. The journey continues into the third stage, purification using aqua regia and gold precipitation. The gold flakes obtained from the previous step look beautiful, but in reality, they are far from pure. They are still contaminated with dust, tiny plastic fragments, and other stubborn metals that haven't dissolved yet, such as silver or platinum. To achieve the highest level of purity, Pakistani workers must employ the ultimate chemical weapon in metallurgy, aqua regia. Aqua regia is not a naturally occurring acid. It is formulated on-site by mixing concentrated hydrochloric acid and concentrated nitric acid at a volume ratio of 3:1. This is a terrifyingly corrosive liquid, one of the very few substances capable of conquering and dissolving gold. Each raw gold flake is dropped into this aqua regia solution. The nitric acid acts as a powerful oxidizing agent, attacking the gold structure, while the hydrochloric acid provides chlorine ions to form a stable liquid complex. Gold, once a radiant and resilient solid metal, is completely dissolved and disappears into a liquid that turns a bright lemon yellow or vibrant orange color. This is the chloroauric acid solution. Once all the gold has dissolved, this liquid is poured through multiple layers of thick cloth or laboratory filter paper to completely remove any remaining plastic debris, ceramic fragments, or inert fiberglass. The result is a transparent, yellow liquid containing all the precious gold in liquefied form. However, since the gold is currently in a liquid state, the worker must perform a critical step before turning it back into a solid: the acid expulsion and neutralization phase. Residual nitric acid still lingers in the solution. If this excess acid is not dealt with, the precipitating chemicals added in the next step will be destroyed and the gold will fail to reappear. To solve this, workers will gently boil the solution to evaporate the nitric acid, or they use a more common and cheaper method in Pakistani workshops, adding urea powder. They pour urea gradually until the solution stops bubbling, signaling that the excess acid has been completely neutralized. Immediately following neutralization, the process enters its most magical moment: gold precipitation. The solution, once as transparent as a lemon beverage, receives a reducing agent poured in by the worker. The most common, accessible, and affordable reducing agent in Pakistan is sodium metabisulfite, though they sometimes use iron sulfate. The moment this reducing agent touches the water, a reverse chemical reaction takes place instantly. The gold ions dissolved in the solution are reduced, turning back into independent, free gold atoms. The solution undergoes a stunning color transformation, shifting from transparent lemon yellow to a murky brown, and then to a pitch black color resembling muddy water. The worker leaves this container or beaker undisturbed for a few hours. Over time, all the free gold atoms bond together and gradually settle to the bottom, forming a fine, dark brown powder. To an ordinary observer looking in, this powder looks no different from dirty mud and appears completely worthless. But to the recycling workers, this is the happiest moment because that brown mud-like powder is actually pure gold, with a purity that can reach up to 99% once stripped of all impurities. Now, we enter the final stage of the entire process: smelting and casting the gold into bullion. The worker gently decants the black wastewater on top, keeping the precious brown powder at the bottom. This powder is washed repeatedly with distilled water and alcohol to ensure no traces of acid or precipitating chemicals remain, and then it is dried completely. Once the gold powder is thoroughly dry, they transfer it all into a small crucible made of heat-resistant ceramic that can withstand intense flames. To aid the melting process, the worker sprinkles a little borax powder into the crucible. This substance lowers the melting point of the metal and acts as a cleaning agent, gathering any remaining microscopic impurities and forcing them to float to the surface. At this point, the worker uses a large, industrial-grade gas blowtorch, blasting a blue flame reaching over 1100 degrees Celsius directly into the crucible. Under the immense heat of the flame, the dark brown powder begins to liquefy. The particles melt and fuse together, turning into a glowing red liquid resembling volcanic lava. Once all the powder has melted completely, the worker turns off the torch and allows the crucible to cool. The glowing red liquid gradually loses heat, solidifies, and sheds the dirty slag layer on top, revealing a brilliantly shiny golden nugget. In larger, semi-industrial workshops in Pakistan, these small gold nuggets are gathered in large quantities, melted once more, and poured into iron molds to create standardized gold bars or bricks, ready to be sold on the open market or to local jewelry shops. The process of extracting gold from electronic waste in Pakistan might look like a lucrative livelihood, turning discarded junk into valuable treasure. However, behind the glittering allure of those pure gold nuggets lies an exorbitant price, a devastating trade-off for both human life and the ecological environment. In terms of human health, the laborers here, including many teenagers and children, face an extremely high risk of chronic poisoning. They don't just inhale corrosive acid fumes daily. They also come into direct contact with lethal heavy metals like lead, mercury, and cadmium found in electronic components. These toxins accumulate in the body over the years, destroying the nervous system, causing kidney failure, inducing cancer, and significantly reducing the life expectancy of the workers. Many of them exchange their youth and health just for a few meager grams of gold to scrape together a living day by day. Environmentally, the impact of this industry in Pakistan is an ongoing catastrophe. Millions of liters of highly toxic waste acid, containing heavy metal concentrations thousands of times above safe limits, are dumped directly into the surrounding environment by workshop owners without a single stage of treatment. They seep deep into the earth, killing vegetation and completely ruining the local community's groundwater. The rivers and canals surrounding these recycling zones have become dead waterways where no living organism can survive. Furthermore, from an economic and resource perspective, this manual method is actually incredibly wasteful. Due to crude and outdated technology, the workers here can only focus on extracting two main metals, gold and copper, because they are easy to strip with acid. Meanwhile, a host of other rare and expensive metals present in circuit boards, such as silver, palladium, and platinum, along with highly valuable rare earth elements, are completely overlooked and thrown back into the trash heaps, permanently unrecoverable. The story of extracting gold from e-waste in Pakistan leaves us with a profound lesson and a powerful warning. Recycling tech waste is an inevitable and mandatory trend for the future if we want to protect the Earth's dwindling resources. However, primitive, spontaneous, and unregulated recycling models like the one taking place in third world countries are not a solution to save the planet. It is simply shifting the burden of pollution and disease from wealthy nations to poorer ones. To solve this problem at its root, the world needs green, closed-loop recycling processes that are strictly regulated by law and utilize modern technologies, such as electrolysis or using microorganisms to safely extract metals. Only then will the concept of urban mining truly fulfill its noble purpose, helping us recover resources without paying with the blood, tears, and future of the generations to come. Thank you all for taking the time to watch this entire video on the fascinating process of extracting gold from electronic waste. Hopefully, this video has given you a fresh and deeper perspective on the tech world behind the devices we use every single day. If you found this content helpful, please leave your thoughts in the comments section below. Goodbye, and see you in the next videos.
ईसा का ये दोस्त है। हाँ जी ठीक है, तू आजा ले आया गड्डी ले आया भाई, तेन रखा देने आजा, नंगे आएगी गड्डी। ये सिस्टम देख गया फिलहाल वो ढीले बन गए और हाँ चल बाकी बंद करके ना उसी तरह कोट के अंदर रखवाना चाहिए। चीज़ में मतलब मेरे को फर्क नहीं पड़ता अगर मालिया जाए चीज़ तरह तो फर्क नहीं ऐसा वो लिया वो मार लिया नहीं कोई मसला नहीं है उधर थी देखो तू गौर ना है माल में चुक लिया फिल्टर के ऊपर आ गया माल ठीक है अच्छा वो तो ना उसे छापर के ना
putar